currently hosting our GCCA 2022 Open Challenge Demo Day, but it's the first Demo Day. As an agenda, after a formal welcome by our CEO, Thomas Giglio, we will have an innovation panel with some of our key members who have designed this demo, this open challenge. And then we will obviously hear from all the startups, which is why I think you are all with us today, and hear from the great results. So without any delay, Thomas, the floor is yours.
Thank you, Claude. Welcome everyone. Welcome in Germany. Thank you very much for hosting us, Martin, VDZ. It's a true pleasure for me to be here with you and to see you all in the room. And for those online, I mean, we have a level of excitement in the room, on a level of joy, on energy that is absolutely amazing. I'm saying that because I feel that this is probably one of the most important launch we are doing since I am in GCCA. We launched the roadmap, and probably this is the second one in terms of how do we walk the talk on how change is happening in our industry. I think you will see today some very example of what is happening on what we do, on why we give ourselves hope in the future. I like to cite that, but when I was in Glasgow 1 year ago, we discussed with some protesters outside the room on the people were telling us, what do you do? What do you do? What is happening there? What do you do in this Glasgow room, in closed door, etc.? And in 2 weeks, we go to Sharm el-Sheikh, and with this discussion today, I know what I will say. We are doing innovation, we are doing these things with you, so I thank you very much. The purpose of GCCA, I will be quick on that one, is really to accompany the cement industry, the cement and concrete industry, through the net zero transition. And in that, innovation is a fundamental pillar of the development. So what we are doing here, we are in the different module of innovation of GCCA. We are discussing product, production, carbon capture, etc. And we have essentially two vehicles for that. The first one is the research network, which is a fantastic network of university, PhD. We have more than 70 PhDs working on different projects, all focused on decarbonation. And the second is this Open Innovation Challenge, which we have launched. We started with 125 startups. We had a first selection at 25 startups, which ended up into 6 consortium, and we have also many of the 25 that are in direct discussion with some of our members. The mission of this accelerator is very much, I mean, I've been speaking to some people in university that theorize the innovation process. And apparently, there is this valley of death for startup. So they say between TRL 3 and TRL 5, 6, there is a moment which is extremely critical for startup when they actually get the innovation on the table and they prove the case to be ready. And I would characterize this process, this exercise that we are doing, literally in helping the startups to go through this valley of death. So we are here to help. We are holding and we are connecting you to get to the industry, to test your technology and to make sure that it's happening and that the things are going forward as quick as possible and as effective as possible. And I thank you for being here again. I mean, we have really some brilliant minds in the room. So I'm very proud and I open the things, again, Claude, showing how the industry is in action, right?
Thank you, Thomas. So I will invite Davide, Zampini from CEMEX. I should actually maybe show who are our panelists. Devika, our innovation consultant. Marios, Katsiotis of Titan, and Raju, Goyal of UltraTech Cement. Just there is one more seat here. Let's make just a little bit more space over there, then I can sit with you. That's going to be a nicer, just dancing a little bit here, but we will make it. We will make it. Do we all have a seat? Yes, excellent. So it's a small conversation, but important one. I think it's really a first experience for the GCCA. We started to discuss it, I think, a bit more than 2 years ago, maybe the initial discussion. I've lost connection. There. Okay, is it working now? Yeah, okay. So, yeah, so I said we launched this challenge in May, already 2021. And from, as Thomas said, from 100 startups, we went to 25, and now we are still with 6 today. So, Edelio, I know that Holcim, you had your own challenge. You ran several accelerator programs. From that perspective, what are the benefits of doing it now with GCCA, with colleagues? What's the benefit of working together, in fact?
So first of all, the main benefit of this joint presenting. Okay, so the main benefit is that this is representing the entire industry. So GCCA is representing the Cement and the Concrete Association, and by having this joint collaboration, we are showing to our stakeholders, be it the architects, the developers, the investors, the politics, that we're very much tackling the climate change issue. This is the main challenge for our industry, and we are all together moving into the right directions. And we know that we need ideas, and the ideas will come from inside, but will come from outside our own organizations. And then this is the main challenge of this organization. And the second challenge that I see in this collaboration is the acceleration, because obviously this is the decade to make it happen. We really need to move into that direction. And we know that alone, a single company cannot afford all the expertise and cannot afford the access and funding to these startups. So that's why having that in a collaborative way, it's the best solution.
Anyone, Davide, you want to add?
Yeah, and I think an important part also is that, you are also de-risking, in some sense, the whole job to accelerate the whole innovation process. So the de-risking is key. So, the industry is coming together to find the right, let's say, bets and challenges and try to move it forward as quickly as possible with the minimum risk.
Thank you, Davide. That's a nice one. We are more brave as a team, or more brave together. Raju, Marius, yes, I will walk.
Thanks, Claude, and thanks, Video. Good opportunity for all the members to accelerate and learn faster and implement faster on that side, because that will definitely strengthen our position to commitment what we made for the net zero, and industry will definitely get the benefit of this all collaboration, whether with the individual company or as a GCCA collaboration, members will get definitely benefit.
Okay, maybe Davide, okay, we work together, but then as companies, I'm sure you all have your own interests. So how far maybe can we go together? For long can you walk all together? But then also, what's next for you as a company? Obviously, we will hear the results, but...
Well, yeah, when it comes to the expectations, I think, I can describe it from 3 perspectives. One is, I think the Innovandi Open Innovation Challenge, was definitely, something new and the first for the industry. And so it obviously brought along challenges, and there's some apprehension when we started. But what we see as an outcome was, the GCCA was great in coordinating, organizing, and putting discipline into the process. The companies brought, their time, resources, and expertise onto the table. And then the startups really did their homework and, really articulated, what is it that it took them, what it would take to take them to the next step. So for me, it created a very, let's say, important dynamism that actually was important to build on, because we have to build on that enthusiasm, that dynamic that is key. And I think the second element of the perspective of what the expectations are from, let's say, a company is that the demo day is by design. So if we're here today, it's because there were outcomes and expectations that they were established when we started this whole thing. So I think if the consortiums did a good job of establishing the outcomes and key deliverables, I think the idea is that the consortiums would hopefully continue to live on and build upon those achievements and and take really what Thomas was saying, let's go beyond the death valley and then and bring it to the next step. So I think that's key. For us as the companies, we want to see the consortium moving on and continuing. And if that is not possible, then I think there's also opportunities have been developed for individual companies to take on further relationships with the different startups. I think the third element, which is also very important, is key learnings. The expectation is to learn something from this experience and build upon it. So I think from the we see from the GCCA perspective that as they are the motor behind all of this, that they are able to, let's say, learn from this process, this approach, and say what can be done better, or what can be improved, or what can be even take us to the next step. From the company perspective, I think one of the things that we surprisingly learn from this is that we have to learn how to manage the relationship with startups. Manage this type of open innovation, and I think the startups walk away seeing the perspective from the industry. They probably walked into this not having really a clear idea what the expectations are, what the industry's like, and that they walk away with this further add-on, and that they can also come back maybe in the second, third round, or who knows what, and with a better value proposition or a stronger value proposition.
Any colleagues willing to add? Marius, I see you are leaning.
Thank you, Claude. And just to add to what Davide said, I believe the key word today is collaboration. It is clear to all of us here that we need to advance our know-how and our knowledge base, and we need to do this together with startups, with the experts from academia, from research, as well as other sectors. And I believe this is a unique collaboration in the sense that this is an industry-led initiative. And to the best of my knowledge, it's to the extent that's happening today, it's the only one out there. So I believe it's a very forward-looking way of collaborating together.
Yeah, just want to add one point on this, what next, what I feel personally on that, because this all the outcome of the 6 consortium that we have, as we all know that one size will not fit for all. So now we have to see that this outcome has to be categorized based on the operations, based on the categories of the plant or location and things, and see that how we can convert this outcome to the pilot, and we have to learn from what comes on the field to implement and adopt faster on that side.
Edelio, you want to add on what's next?
Just a very, very small one. That is opportunity for the startups to get some fundings, because the awareness and the fact that the GCCA is supporting these initiatives, I hope that it will leverage a lot of opportunities for the startups.
Thank you, Edelio. Devika, we haven't heard you yet, and I want to link to what Davide said about, connecting the startup world with the cement industry world. And when we launched this challenge, we were happy enough to meet with Devika, who had this amazing triple experience of startup world, cement industry, and carbon capture. But I think Devika has helped a lot this process of talking to the startups, understanding what you needed were, and actually bridging those two worlds. But Devika, in which way has it been unique, and in which way is this GCCA Accelerator a unique program?
Thank you. I think a lot of it has already been said, but just to sum up what everybody said, when we started this challenge, it was important to understand, I understand where startups come from. Everybody wants to accelerate their technology, we want to commercialize. But we also had to understand the perspective of the cement industry as a unit. It was not just one company, but there were so many members that were on board, and it was important for us to devise this challenge. The benefit of working, I think we've already mentioned, Edelio mentioned, Davide mentioned, collaboration is the key for us to move forward. But the uniqueness in this challenge was we had a matching exercise that we did, how to match the startups to the expectations that members have, or how to match the expectations that the startup have to match it with the members. So I think in this matching exercise when we came up with different consortiums, and the added advantage that happened with the startup. So we have 6 consortiums that are live today, but there were 21 startups that we started with, and almost all of the startups have different opportunities. It has opened different doors for them. They have received additional grants. So I think the uniqueness of this challenge is not only that cement industry is bringing the experience, but they are also pushing the startups to think a little more, little ahead, because the only way to accelerate is if we work together. And I think that's the key. Yeah.
Anyone willing to?
I think, one should not underestimate. I mean, I think there is a lot of work to bring these 3 worlds together. No, I mean, the association that's trying to bring the industries together, the companies that have their own agendas, but at the same time have to learn how to work as an industry, and the startups who are coming in and seeing this for the first time, for many of them, and also for us to literally understand what's driving the startups. I mean, putting all that together, I mean, is not an easy task, and I think there's a lot to be said for that, and what Devika has been able to achieve in the association and so forth. So,
Thank you.
Yes, perhaps just a last word. It's unique because this is the first time we do it, and that's something which is very, very specific to the Cement and Concrete Association. There are not so many industries doing the same under an umbrella, which is a global association. So that's unique. And that will be unique because that's a success. And we hope that this is just the beginning, the first round, there will be a second round, etc. So.
And of course, we will improve. So lessons learned are important, and we are obviously open to everyone's feedback on how can we do better next time, because I'm sure we can still improve. Marios, we heard from Thomas. GCCA has 2 innovation arms. One is a huge consortium, pre-competitive research, tying up together academics with the industry and equipment suppliers and admixture companies. And then we have this open challenge. So we are now looking outside to the academic world, outside to the startups. But what's the best innovation strategy? And it's always this question, outside in or inside out, and how do we have to...
Okay. Well, Claude, thank you for the question, and I can already tell you that we need both approaches, and that is because of our need to continue offering products that are durable, they're sustainable, they're long-lasting, they're available globally, and they're affordable, while at the same time we decarbonize and we digitalize. And to do that, we need to advance our understanding of what is feasible for our products today. We need to push them to the boundaries of what is feasible realistically. And at the same time, we need to expand our knowledge, we need to expand our skill set on new fields of science and technology to make that advance. And allow me to elaborate a bit further, starting with digitalization. It offers ample opportunity to revisit the way we produce our products, the way we offer them to our customers, the way we perform logistics, the way we interact with our customers. And there's many wonderful examples of digital tools being used to enhance the way we produce and offer products and services. And one of them, and if I may mention it, is also CEMEX, an affiliate of Titan Cement Company, which offers predictive maintenance as a service to other companies based on AI technology. Now, referring to decarbonization and with reference to our GCCA roadmap, we note that there are efficiencies in design and construction and concrete use, and also savings from the way we make cement and clinker. And that has to do with promoting our understanding of the material, of making the best use of the reactive yet also carbon-intensive components of our products towards net zero buildings. And as we know, this is one part of what we can do, and there is also, because of the nature of our carbon footprint, there's also activities related to new technologies such as carbon capture, the reason why we're here today, carbon capture utilization and sequestration. There's also other technologies such as renewables and hydrogen. And this is, broadly speaking, this is relatively new to our sector, and we need to build that capacity. We need to interact with the relevant stakeholders, not only to develop the knowledge, but also to build the ecosystems. We're talking about initiatives and projects that require significant assets and preparation. So there's a number of stakeholders that we need to engage with, and obviously the startups are a critical component towards that. So to sum up, we need to make advance on both the front of decarbonization and digitalization. It requires us to develop new skills. And we need, and I think I also need to mention this, we need to make progress on different sides of different levels of technological maturity. We need to advance ideas from concepts to development all the way to scale. And it is obvious we need this kind of innovation to move forward.
I also see that the research network, what we have, is like what we know, and we want to build on that to excel in our efforts and our achievements and our commitments. And Open Challenge bring us what we know, beyond that what need to be done, because all cement industry, we know how to emit the CO2. Now we are learning that how to control and how to abate that. So this Open Challenge is give us the opportunity to learn from outside world, outside like startups, other brains, because we are know only hardcore manufacturing, how to make the cement. But now we are learning that how this can be transformed into, like you said, in the energy terms or efficiency terms, or changing our way of doing the things in our business. So that's also very much important for us. After this demo session, where I learned that we can learn from faster from the outside world also, not only what we know, and we can build on what we know also.
I'll just quickly add also is that I think what Mario said also was very important, even though we didn't say it directly, but the AI and digitalization is also, something that underlines that the fact that the industry is not just only focused on maybe the topics that are most closest to us, but the innovation space we're seeing is opening up to a much broader, let's say, spectrum, and we're not just only focusing on what we're doing day to day or what is obvious. No? So I think that's interesting.
Thank you. And I have a last question, and that's to you, Raju. Thank you for making all the way from India to us. And I think we should also thank our Japanese colleagues who went around the world to be physically present here. And we are a global organization, but I want to truly acknowledge your effort. But also, we have seen we have less startup from Asia. Let's be clear, India and Asia. We have been less good, maybe, or less efficient at sourcing startups from there. Are there differences in the world, or is it just that we didn't get the sourcing right, or what can we do to do better next time?
Thanks, Claude. This is a very loaded question. Let me divide into the few parts of that. So I think indeed there is a difference in this part of the world and the Asia on that side. So let me define this in the two categories, this difference is. First category is coming to the diversified industry. When I say the diversified industry means because in Asia, some of the multinationals are operating, some of the big entrepreneurs or conglomerates are working on that, which are big companies. And in between, there is a small or middle to lower side of the size of the companies are there. So very wide landscape what the producers as well as the maturity of the industries are there. Second part, I'll say that in Asia, I will put up a triangle, one called the economical development part, which is happening because the developing country side, and second comes the social inclusion. And top of that, we come to the climate change action or commitment. So this three triangle, I think how to bridge this, all the 3 points and bridge this connections between these three, I think that will drive the whole public and private financing and public interest in that. And top of that, there's a government also taking a lot of initiative right now. I think you say that like China, South Korea, and India is very much ahead of this, making the commitments and making the calls. Let's take the example of the India, if I can tell this example now. Reserve Bank of India is announcing now 7-year green bonds. That will definitely encourage the private as well as the public fundings for the all innovations or all the projects towards our net zero, and other innovations will be coming up there. And if I also take part of that, please allow me to say that on the GCCA point of view, as you rightly said, I believe that in India, the GCCA presence is known by only the few top companies so far. I think there is a number of companies which we can engage them by communication, by contacting them and talking to the associations. Because when you said the BDZ here, this came to my mind in that, because in Asia also each country has associations. How we can leverage the network and and we can communicate or contact them and bring that to the portfolio. And second, I'll say that if we can also think for that, making seminars, conferences, or road shows in the countries where we do not have or making much more exposure for the GCC activities. As soon as people know that what GCC can offer, because whether it's small player or the top player in the market, everybody has the same problem, and they want to fix it. And when we talk about the entrepreneurs or the big companies, they might have some resources and capabilities to do something, but middle level things may not be having. So that will be a good opportunity for GCCA to go there and help them to build this whole network, and that will definitely bring the financing, funding, and new projects and new startup will be come from Asia also. That's I believe.
So a couple of things. I think Raju added everything that I had to say, but I think there are some key points that are important here. This, like we said, that this is the first time it has happened, industry and startups working together to develop the future. But I think in the first challenge, yes, there were inhibitions from the startups, and there were inhibitions from the members as well. So I think today it's a significant day for the whole community, because it's the results that we are going to showcase today. It will definitely bring in a lot of more confidence with the members that yes, this can be done. It's not something that looks vague, or we might not be able to share a lot of information. But I think the work that we have done in different consortiums, we had different styles of consortiums here. It's not the same, but what is important is members know how to work together, and a startup knows what is expected. So some of the startups that we sourced had never worked with a cement company before, so they had no idea the challenges that you have, which will come only from, I don't want to call it mentoring as such, but I think that was a very important learning that we had with startups. A lot of technologies have never worked with cement. So I think that insight that comes from the cement industry definitely helps them to do better. And we saw some of the startup technologies evolve during this whole process of the Innovation Challenge. Yeah.
Thank you very much. I think we have been amazing, because it's one shop. But I know that everyone is really now impatient to hear from the 6 startups. So a big thank you to the 6 of you. We can clap, why not? That our online people feel the energy in this room. Thank you very much. If you can just help me, if you could all push your chair back on the wall, then I make some space, and then Natalie, you can get ready. And then we make a little bit of space so that you can move. it's okay, Hazel, I think this way. And so let me get your slide. I'm doing some housekeeping. So those are obviously our 6 startups. I know that we had a question in the chat. I think we have now posted the timing of the 6 startups, but I think they're all worth staying online with us for the next hour and a half. So stay, 6 startups, and then an announcement by Thomas on what's next. So don't leave this call. And I think, Natalie, everything works. So carbon upcycling, and I won't say much. I know your startup has earned some prizes and that you are not only in this open challenge, but the floor is yours.
Thank you, Claude. Can you hear me on this one? I think so. Awesome. Yeah, so good morning, everybody. My name is Natalie Giglio, and I'm here representing Carbon Upcycling Technologies today. So Carbon Upcycling is a Canadian company. We are located in Calgary, Alberta, Canada. I lost myself. Oh, there we go. On the west coast of Canada. So Carbon Upcycling is producing the next frontier circular materials. And we're doing that by looking at different industrial products and natural minerals in order to access, here we go, to produce materials that are local to cement plants that help them decarbonize. So Carbon Upcycling's technology is a single-step, low-energy process that captures CO2 into materials to create high-performance cement replacements. So we've looked at everything from treating those industrial byproducts to natural minerals, really opening up the landscape of what's possible to become a cement replacement. So across those different materials, we've seen a range of results. We've been able to do 10 to 50% in cement reductions in ready-mix concrete. We are looking at improvements in strength, averaging between 20 and 40%. And we also improved the durability, which is another aspect of that longer-term deep decarbonization that we're looking at within the industry. And then, as a result of all of that, reducing cement, improving durability, we've been able to quantify about a 50% reduction in carbon emissions if we were to be at full scale. So carbon upcycling has been around for the last 8 years, and we've been primarily engaged with the cement and concrete industry. So it wasn't our first time engaging with some of these players. So we had a little bit of a feel of what this was going to be like. So our consortium had 6 members. It was a CRH, Vallejo, Holcim, Argos, Shri, and CEMEX. And we sourced 7 different materials from around the world and treated them at our facility in Calgary. Let's see. There we go. I think I'm blocking the receiver. There we go. Carbon upcycling was able to produce these CO2-enhanced cement replacements using our technology. And we looked at a couple of different parameters through different strength performance testing, chemical analysis to come up with our verdict if these materials were suitable for our process. So we see a reduction in particle size in the material. We increase the amorphous content, which helps to boost the strength activity of the material. We decrease the water requirement, making it a more sustainable material, so you don't have to use as much water. And we were able to determine different levels of CO2 absorption across the different materials. CO2 mineralization is it's based upon chemistry. So some materials are really good for carbonation, some don't present a good opportunity for carbonation. And so we have to weigh the balance of, we get a lot of a strength improvement, but how much carbon can we capture? And when we looked at the results from this study, we saw there was a range in both strength improvement and CO2 uptake. So this table is a lot, so I'll try and summarize it for you because this was the findings of our program with the GCCA. So we looked at everything from aggregate fines to natural pozzolans, pond ashes, blast furnace slags, and ground granulated blast furnace slags. In the strength column, you see everything from just a couple percentages in increase in strength all the way to 100% increase in strength with one of the pond ash samples. So that's the one parameter to consider. Then we look at the CO2 uptake, and this is where we did a bit of a chemical analysis. So you can see that some materials don't have a lot of strength, but they have a high capacity to mineralize CO2. Other materials have a lower possibility to capture CO2, but we can double their strength performance. So there's a balance here to strike between what we can achieve from a material performance perspective and what we can capture in terms of CO2. So these are the two parameters we really look at in determining the feasibility of a material. And so at that very last column, we made the determination that 5 of our 7 materials were good candidates to consider future testing with, to do some more analysis on the chemistry and on the strength performance. And we determined that one of them was probably not a good candidate, and then one is to be determined. We had a bit of interesting results, so we're going to pursue that one further to figure out if we would recommend it as a candidate. So what does this mean as a path forward for the cement industry? Carbon Upcycling's technology is designed to integrate right at the cement plant. So we can take CO2 and bypass it through our system, capture some of that CO2 into the material, and then that material stays at the cement plant and gets blended into the cement through the finishing mills. And then that cement can go into ready mix or precast. So we want to stay right at the source of CO2 and then help push out a more sustainable product to market. So from our material study, we determined that several materials were viable candidates for our process. And so now the path forward for us is looking into those materials at a deeper level and going forward and doing some feed and engineering studies at the plant specifically to figure out what that pathway of integration looks like at each unique cement plant. And this is really how we want to bring our technology to market. And with that, I don't have anything more to say. I know Cloud was maybe going to take some questions if we have time, but I thank you for your attention and the opportunity to be a part of this program. And I look forward to continue to working with many of the companies in this room today. Thank you.
Thank you very much. For the colleagues online, you can also ask questions, and we have 2 minutes with Natalie. There are no questions online, so either it was fantastic or people didn't know they could ask questions. In the meantime, any question here? Please, I'm sure you have questions, so I need someone to break the ice. Edelio.
How long do you need to be operational? What is the timeline for the development?
Yeah, so we have been operating we call a semi-commercial pilot plant in Calgary, Alberta, and we're right now building the next size that's going to process 50 tons of material per day. So on an annual basis, you're just under 20,000 tons, which is a small amount in sort of the grand scheme of what cement plants produce, but that's our next step of integration. And we have just announced grant funding with CEMEX with a UK plant to actually launch that 50-ton per day system at a cement plant in the UK. And so that will be operational hopefully by the end of year, or end of year next year, not this year. I couldn't even imagine if we tried to do it by December. But next year, at the end of the year, we should have an operational plant at a cement facility, and I would love to do a GCCA tour of that event and that plant once we have it up and running to see our technology in the field. Thank you, Edelio.
I think we take the invitation, Thomas.
Yeah.
Okay. That's nice. And in the meantime, the online audience is waking up.
Okay.
We have a question. Sorry, I need to move away apparently from there. The question is, what kind of technology do you use to capture the CO2?
Yes, so our technology is a sort of a two-step process. We have a mechanical activation of the material that helps reduce the particle size and activate the surface area, but at the same time, we're facilitating a chemical reaction, which is taking that CO2 and mineralizing it onto the available calcium oxide, magnesium oxide, other oxide profiles in the material. So it's a two-step process, the mechanical activation and then the chemical reaction that's capturing the CO2.
Thank you. And one here. There is another one online, but let's take yours.
Yeah, thanks for the presentation. Question to add on your last words. Do you need captured CO2, so concentrated CO2, or can you also work with flue gases directly?
Good question. We can use flue gas directly right now from the cement kiln. So we can use that lower purity CO2, but we're not limited to that. So as carbon capture comes online, we can switch and take a bypass stream from a capture unit as well.
Okay, I just want to take one online, if I may, and then I think we will have to stop. You can still ask the question later this afternoon. Yeah. So what investment is required?
Good question. So our 50-ton per day system that we're deploying next year, it's going to have a capex from around $3 to $4 million US. That's what we're projecting it to be right now.
Thank you very much. I think we are just on time. I think another round of applause for Natalie and Carbon Upcycling. Thank you. I'm trying, as we are moving on, I set the rules. I try to privilege online question because you can always ask your question afterwards, but if we have no one online, then I need you to animate this, okay? So all burden on you. With this, we will move to our next startup, and this is MOF Technologies. And this is what I like with this challenge is that we have really seen a lot of different technologies. So pass you the baton, and I mute my mic.
Hopefully you can hear me okay. My clothes? How's that? Okay. I'll stand like this, power pose. Guys, thanks very much. My name's Conor Hamill. I'm the co-CEO of MOF Technologies. Very excited to be here today to discuss our next generation carbon capture technology. MOF Technologies is a Belfast, Northern Irish-based startup company. We're very excited to participate today to showcase to the GCCA community the exciting next generation ultra-efficient capture technology that we've created. And I think, as the speakers alluded to today, what is very evident is that we are at a state of emergency, climate emergency. We're all very aware of what the coming consequences are unless we act now. And whilst the exact route to net zero is still up for debate, what is clear is that carbon capture has a critical role in being able to deliver these targets. And carbon capture technologies have been around for many decades, but I think, it's what I'm sure a lot of people in the room understand is that the rollout of these technologies has really been hindered by things such as the cost and the sheer energy demand associated with operating these systems. And this is where MOF Technologies comes into play. At MOF Technologies, we harnessed the high-capacity, selective nature of an advanced material called the metal organic framework to engineer our very own filtration system to capture and release CO2. We've paired this with a mature capture technology in the form of vacuum swing adsorption, which enables us to be able to capture and release that CO2 in an ultra-energy efficient manner. So how does this work? Effectively, this ultra energy efficiency can be achieved by using pressure rather than heat. As you can see from the little animation here, what we effectively have is this filtration system comprised of our MOF component. It captures those CO2 molecules very, very efficiently. And once that filter becomes saturated, the key thing of what we're able to do is rather than apply heat to break chemical bonds, we're able to just change the pressure and release that CO2 again in a very pure form. So effectively, if you think about it, what we're doing here is essentially vacuuming the carbon dioxide out of the cement plant. So by being able to leverage pressure rather than heat, what does this mean in terms of operation? Effectively, what we can do is cut that energy usage for carbon capture by up to nearly 80% versus some of your state-of-the-art scrubbing systems. And this is a true step change in terms of how we operate carbon capture systems. And consequently, because of this, we don't need heat, steam, we avoid complex integration, which ultimately brings down that cost of capture. So it's enabling the cement industry to be able to achieve its net zero targets, ultimately impacting the bottom line. And through the GCCA's Open Innovandi Challenge, we have had the unique opportunity to go and pilot our next generation technology with some of the three of these innovative companies here, Bootsy Unicem, Cementier Holding, Heidelberg Cement. And we're very pleased to have had this opportunity to work with the GCCA, understand the dynamics of the industry. Through this challenge as well, we've also been able to leverage the relationships that we've built here to be able to raise additional funding for our company, which is again helping to propel the company forward. And where we are today, what we're planning to do through the GCCA and through the members is that we are building a 1 ton per day pilot plant. And this pilot plant will be located in Bootsy Unicem's site in Montsilecce in northeast Italy. And this fully 1 ton per day plant will validate the energy efficiency that can be gained with our exciting metal organic framework-based capture technology. And through the program to date, as you can appreciate, building a pilot plant is not something that can happen overnight. We wish it could. But what we've identified the site through the work with Bootsy Unicem, conducted the needs analysis to really formulate some of the constraints, the challenges that we may face deploying the pilot in Montsilecce. We've conducted conceptual designs, we've conducted flow sheeting of the process to understand how we can integrate and configure this to the site. We're now at a stage where we're hammering through into the detailed design, and we're looking to construct, install this plant and have it operational for the summer next year. And through doing this, we're very excited that this will finally be able to showcase the potential of the metal organic frameworks to be able to help decarbonize the cement industry. And this is the beginning. Post the GCCA challenge, we plan to go big, we plan to go fast. And what's unique about our technology is the vacuum swing adsorption technology has already been scaled. It's a technique that is widely used in the oil and gas industry, in the gas generation space. So those supply chains and manufacturing capabilities to be able to produce plants of the scale required to works already exist. And we're confident that we'll be able to leverage those capabilities to be able to build our next 100 ton per day demo plant to give the community or the ecosystem additional confidence that this technology can transform the future. And as I say, we're very excited to continue on this journey with the GCCA, and we look forward to hopefully welcoming you all to Montsilecce. If Marcus is open to that, to welcome the GCCA and the members to see our exciting. So I thank everyone at the GCCA for this opportunity, the members, and in particular to Devika for the patience that you've had with us over the past period. And yeah, we look forward to the exciting journey ahead. Thank you. Hopefully no interference.
Hopefully I don't dare to come too close to you.
Quarantine.
With all my I don't know, interference. Thank you really much. We actually have already one question live. What is the durability of MOF systems?
Yes, this is one of the misconceptions that people have. So metal organic frameworks, we have demonstrated at a particular scale, and we're looking to use the program to advance the TRL, but we've showcased the ability of this material to capture and release CO2 on over nearly 100,000 cycles without seeing any change or degradation in that performance. And that's, again, performance demonstrated in the presence of moisture, some of those low-level contaminants that you would typically see in flue exhaust. So, we're very excited to, validate this at the next level in showcasing its ability to treat, flue gas from a real site. But we certainly, within our sort of financial forecasting, we're looking at quite conceivably and conservatively a lifetime of 2 years for the filter, whereby it will be changed out and reused again.
Okay. Keep coming through, so you can still all stay quiet. How much pressure, positive, negative, are we talking about?
We actually go negative. So as I say, we're effectively vacuuming that CO2 out of the cement plant or out of the flue gas. So we're dropping the pressure from just slightly elevated atmospheric pressure, so just super atmospheric pressure, and we're bringing that down to sort of the circa the region of 5 kPa.
Okay. Playing with this mic, is there any pre-treatment needed before MOF?
Again, this is quite case specific, and it'll obviously depend, on the needs analysis for particular sites and understanding, composition of flue gases are. But of course, similarly to what you would see with some of those amine scrubbing systems, of course we need to, cool down that flue gas, get it conditioned to a temperature that's optimal for our system. Of course, some heavy metals as well as some particular gases. Again, there may need to be some treatment upstream of the VPSA system itself.
Okay, you're really generating a lot of questions. I think kind of durability. There is one question that asks about the lifetime in terms of cycles, and it goes on with what's the situation in terms of scaling up the technology?
As I say, we're very excited in that, those supply chains and capabilities for VPSA already exist. There's plants worldwide today which can be used to treat a full-scale cement works. With respect to the filters and materials themselves, again, at MOF Technologies, we've already scaled this aspect as well, so we can produce these materials today at a ton scale in a very economical manner. So again, we have no concerns about scalability. It's just this is the next phase for us is about validating in field and then moving to this next level to generate additional confidence for users to adopt the capture system.
Yeah, I think you answered, but there is one question. Any pilot installed so far, and what's the capacity? Or maybe in another sector?
We are exploring. This is a point source carbon capture system. So again, there are sectors where this is applicable. Through the innovation and the foresight that has come with the GCCA, this will be our first pilot of this technology in field. So it's very exciting to be working with the members who are really, taking the bet on showcasing this technology with us. So this will be the first pilot, and it will be 1 tons per day.
Okay, now that's I think that's exciting, and that's where we want to bring all the startup sites to pilot. Maybe a last one. Can you talk more about the material that is used in the framework? This is from someone anonymous.
Oh, sounds very clandestine. Unfortunately, we can't reveal what the exact composition of the material is, but yeah, it's a trade secret, the secret sauce.
Okay, if I may, I go in the last one that may be related. No, maybe it's the same anonymous attendee asking the question in another way.
These guys over there.
Do you see? They might be, actually. That's why we have a lot of questions. Do you see any challenge related to the availability of MOF raw materials?
No, we don't see that. We have been in the business of manufacturing, producing MOFs for nearly a decade, and it's more recently, in the last number of years, we've harnessed all that know-how we have about using these materials, applying these materials to create this capture system. So, again, from a materials perspective, we don't see any risk in terms of scaling this up. We've already done it. We've already produced this material at a ton scale, and we don't.
Thank you. Thank you very much.
Thank you very much, Claude, and thanks very much to the GCCA.
Well done. Well done, and good luck with the pilot and the next steps. So I will invite our next startup, which is CarbonOrO. You're ready?
I'm ready.
So, Pieter?
Is this working?
I think it works okay.
Good.
I will walk away. You got the button from the colleague?
No.
Where is it? MOF, you have stolen the... No? Where is it?
This is working as well.
This is working well? Okay.
Yeah.
Okay. Let's try to find it for next.
Ready to go? Yeah, I on the computer. Okay. Okay, in front of you is a happy man, not because the technology is not working, that's not the issue, but of course to have the opportunity to present to GCCA members, first here in Düsseldorf, but also online. But secondly, I'm so happy because yesterday CarbonOrO signed into a letter of intent with external funders. So we have some investors now coming up that are as excited about our carbon capture technology as we, the three founders of CarbonOrO, and that's a huge step, of course, for our company. Let's go to more. I can also give you some idea about what we are doing with our CarbonOrO technology. About carbon capture and amine systems, and we use an amine as well to capture carbon. The amine we use is very It's called the biphasic amine, and that allows us to use less energy and to produce CO2 at elevated pressure, saving on cost in general on carbon capture systems. If you look, what has happened here? If you look at the uniqueness of the biphasic, let's show it here. This is a biphasic solvent that we use, and you see it on the left side at 40 degrees. It looks a bit milky. It's a very thin emulsion, but when you heat it up, it splits in two fractions. Actually looks like a spoiled mayonnaise, so it's oil and vinegar on top of each other. And the nice thing from the carbon capture perspective is that the CO2 is not contained in layer number 1 and not contained in layer number 2. So it actually bursts out of these two layers. And you can see that on this small video that was taken in our lab. And here you see it's operating at 85 degrees, which is a relatively low temperature. And the CO2 is actually bubbling out of the solvent. So operating at low temperature with a lot with energy advantage over the traditional solvent in the industry, which is called MEA. We have done feasibility study last for another industry, in fact a hydrogen plant of a big chemical producer, and it showed that our solvent is about 32% more efficient in cost than the typical MEA solvent, and it's even further count the savings from the higher pressure, so also saving on compression and liquefaction on CO2. Origin from that is one, the lower capex. Our solvent can contain slightly more CO2 than the traditional MEA solvent can, so we need less solvent and also smaller pumps and smaller installations. Secondly, it's the energy consumption, and thirdly, it's the CO2 that is produced at elevated pressure. Also, modular and design. Installations up to about 100 kiloton capture capacity for roughly 20% of CO2 that can be fit on containerized frames that can be built off-site and shipped on the location, so you don't need any building activity or minimal building technology on site. Amine degradation is also reduced. Our solvent in general to oxidative degradation, and because of the low operating temperature, also the thermal degradation is reduced. What has happened with the slides? So 2 slides are missing. I don't know what happened here, but let's do it. Working now on 2 particular pilots, 10 kiloton per year pilots. One is with the biggest Dutch waste management company called AVR. What we want to prove there is that also our solvent works not just good in the lab, not just on a small scale, the 2 kiloton scale we already captured, but on 10 kiloton scale in an industrial environment. Second pilot is funded by the European Union. In fact, Upcycling technology is also part of that particular pilot, and it's about carbon capture and use, so producing without to fill a material that can be used in bricks and also could be used in other building material. What we have done with GCCA, and we worked with 6 different members of GCCA. First, we worked on defining 2 representative cases for GCCA, building on the SEMCAP specs, 20% case and a 30% case. Looking at an 800 kiloton, more or less, CO2 flow into the flue gas and actually capturing more than 90% of it, so 730 kiloton per annum of CO2, but the purity CO2 above 99%. The study itself, the feasibility study, was not executed by us, but by a third party, an independent engineering company from France, Sofacit. And it showed that actually the capex of such a huge installation would be roughly 167 million euros. That is the total cost from going from the greenfield to an operational unit. So not just the carbon capture part, but also everything that is related to heating, to cooling, getting disposed of waste, cleaning of streams, etc. Roughly 1/3 of that 167 million relates to our part, so the carbon capture part in general. If you look at the reboiler duty, which is a characteristic number for the OPEX, it's about 2.5 to 2.7 gigajoule per ton, depending on the case, which compares very positively to the 3.8 gigajoule per ton as it is used in the SEMCAP spec. What we want to do from now, and I thought that was on the screen. Of course, we want to move forward with GCCA to the next level. Actually, scaling up, working on the existing relationships to build up. We had with GCCA, the very good relationships, also thanks to Devika for the great work. And now we are open for discussions with GCCA members to join in the pilot, to agree on test plan specifications, and to probably also have the involvement of other EPC parties that may work with us on the 10 kiloton per scale or even beyond that. Okay, thanks.
Thank you very much. We will check the slides and make sure that we make the missing slides, if any, available. In the meantime, I would like to find this pointer for your colleagues, because it's here, in fact. So, okay, I'm really sorry.
I think the missing slides were worse than the missing pointer.
But you did really great. Thank you. This is the risk of being live. So no question coming, or yes, just a minute. High pressure, or is that still one for MOF? No, CarbonOrO. Okay, first one, 2.5 gigaton CO2 capture for CO2 delivered, at which pressure, temperature, and question mark liquefied?
It's about 35 degrees Celsius when it comes out of our installation. And there it's produced at roughly 46 bars, and then it can be taken up by compression. So our focus is on the carbon capture, which is 46 bars. From there, compressed, liquefied, depending on the transport or application.
Thank you. How high? What's that? Yeah. Okay. How high pressure process? requirement reduces electricity consumption?
Not from the top of my head. I can't do that.
Okay,
no.
that can come later.
But we have a 100-page report for GCCA. So.
Okay. Another question that says that your summary on the GCCA website says you have a full-scale unit for a waste company in the UK. Can you provide more details on that?
Yeah, we have built an installation for upgrading of landfill gas with a waste company in the UK, built at 2 kiloton per annum capacity. But of course, the focus there is not on CO2 capturing. The focus there is on producing methane out of landfill gas. But the technology is the same, but the ingoing qualities of the gas are quite different because landfill gas typically, or that particular site, has roughly 35% of CO2, so slightly different.
Thank you. And I have another one. How has the system responded in dusty flue gas?
That's what we need to find out in this industrial pilot. On this particular site in the UK that I mentioned, there is a dust filter. And also in our installation, we need dust filters. We need also a pre-treatment of the flue gas comparable to every standard amine system. So you don't want acidic components in it. You don't want dust in it, SOx, NOx, etc. That needs to be removed.
Okay, thank you. Any question from the room? You were not prepared. Thomas.
I'm not sure you said it. What is the efficiency of carbon removal? I mean, the percentage of CO2 removed?
90% plus.
90% plus.
Yep.
Any more? No?
Davide.
Just check here. Davide. We need to use this, otherwise our colleagues...
More philosophical. Did you have fun?
During the presentation of working on the project. Work on the project, yes, we did. And hopefully, as said, we continue to work together on a joint pilot.
I actually have another, not such philosophical question, but maybe it's a question in the chat. What is the importance of amine scrubbing for CO2 capturing?
What is the importance?
Yes.
In fact, it's the only, let's say, standard industry solution now available, more or less. Yeah.
Okay.
At scale, I should say.
That's quite important.
So,
looks like we are done. Thank you very much.
You're welcome.
And the next one is Coomtech. I will go away. So, Richard, you have the pointer, which was hidden.
Okay.
And I cut my microphone.
Okay, so I'm Richard Atkinson from Coomtech. We build low-energy drying equipment. So perhaps different to some of these others that you've heard about here, we are not doing something that you're not already doing. We offer the opportunity to do something that you're probably already doing at a much lower energy cost. So this slide, basically, I don't want you to read it all now, it'll be in the presentation pack, but it describes the conventional way of drying things. And the conventional way of drying push it through the latent heat of vaporization, and if you remember your high school physics, that is a very energy-hungry way of doing something. The way that we do it is basically mechanical. So you probably use those Dyson hand dryers that shear the moisture off your hands using high-speed air. We basically do that at an industrial scale. And we do that for construction materials. So we've done that for cement, for fly ash, limestone, GBFS. Essentially, if you can pneumatically convey it, you can use our technology and you can save about 3/4 of the energy that you're using to dry things. So this is our equipment. I want to draw your attention first to the schematic and then to the picture on the top right, because the other two pictures are basically the development journey to get us to where we are. So this pipe that you can see here is where we dry the material. So we drop the material into an airflow and we fire it down that pipe. And on its journey down that pipe, it meets a sequence of air knives. That is, it meets a sequence of counter airflows at very high speed that shear the moisture off the surface of the material. So at the left-hand end, you've got wet material and a dry airstream. In this process here, the airstream removes the material from the moisture, and then, as you might recognize, a cyclone at the end is where the now wet air is vented to atmosphere and the now dry material is dropped out into a container. So that's it. It's very simple. It has no moving parts in the main process. And because we're just using a mechanical method to remove the moisture, it's a lot less energy than thermal drying. The top right-hand corner picture is our pilot plant near Manchester in England. That's about a 1 ton per hour facility. Our first production unit is a 4 ton per hour facility. It'll ship out of the UK in a couple of weeks and is going to Australia. So I'd like to thank here UltraTech, JSW, Boozy, Unichem, CRH, who were our partners in bringing this technology through the program. The objectives here to look at some different materials that are of interest to GCCA members. And I think the consortium members picked quite a wise selection of materials because it ranged from things that are very easy to dry to things that are very difficult to dry. So in the selection materials that they chose, we've that the industry uses across a wide and representative set of materials. As it says at the end, we've done this in 2 stages. First, an evaluation with just a 5 kilo sample, and then later with a 500 kilo sample, a production evaluation where we put it through the machinery. These are some of the results. Now, due to some logistics snags, we haven't done as much of the production samples as we hope to do, but we have been able to do all of the initial evaluation. So when I say it's a well-chosen selection, GBFS at the bottom of the upper block is at the easy end of things to dry. It's very free-flowing material. All the moisture is on the surface. It's very well suited to what we call kinetic drying, to drying it in an airflow. At the upper end, sewage sludge, that's a much more difficult material. And although it's hard to do, it's quite informative because it reveals to you what the limit conditions and what the range of possibility is for this technology. And the other two fall somewhere in the middle of that range. Pond ash is the first one that we will be doing a production run on. That's something that we have got quite a lot of experience with. And in fact, our second unit sale is going to a ponded ash, fly ash harvesting site in Nottingham in England, and should be operational in the spring next year. So this gives you a bit more detail. I'm going to back up a bit, sorry. So this gives you the moisture here on these materials. Typically, our product's suitable for anything up to the high teens in terms of moisture level. Here what you've got is some commentary, and I suggest you read this later on rather than trying to keep up with it now. Commentary on the suitability of the material, approximating somewhat. If it flows easily, it's going to be easy to dry. If it's sticky and coherent, it's going to be a little bit harder to dry. That doesn't mean you can't do it. That just means that you will probably need to think carefully about the processing that you use ahead of drying in order to prepare the material. And I think that takes us to the end. So.
Let's go back one slide because I'm sure we will have questions. Yeah. Thank you for your presentation. Nothing, and yes, I have what? Sorry, and then it's yours. Then they can prepare one. What investment is required to adopt this technology for drying of pond ash with moisture content of more than 20%?
Okay, so I'm going to make a distinction between dewatering and drying, which you may be familiar with if you already worked in this field, but dewatering is kind of mechanically removing moisture from things, and drying it is what you have to do when you've reached the limits of mechanical or wind and sun dewatering. You should always dewater to the extent that you can, because dewatering is much, much cheaper than drying. Ash is about on the border between those two requirements. So usually we would say to people, look, dewater down from, you may be starting at 30% or more, down to about 20, if you can, into the mid-teens, and then dry. So our machinery works best with fly ash, it works best from the mid-teens down. In terms of the cost, for a typically, let's say, 4 to 6 ton per hour unit, that would be about 700,000 US. So that I want to caveat that answer because it's a very shoot from the hip. It all depends on your particular situation, how you are going to configure the plant, the trade-offs that you choose to make, but it's of that order.
Thank you. And now, Natalie, maybe you need Coomtech.
Yeah, well, we've chatted before, but how long is the tonnage pilot that you guys are using?
The easy way to answer that, the shadow on this picture here, so it's about, I think that's about 35 meters long, 2 shipping containers. We build these into a shipping container dimension frame, so that means that they're easy to ship. It also means that they are demountable. You could site this somewhere, run it for a season, pick it up with a crane and move it somewhere else.
Thank you. More question. What is, or at least one more, what is the approximate velocity and air requirement per kilo of material?
Okay. I can't give you the numbers in that unit right away, but for a single module, it's about 4 to 6 tons per hour. It is using, I think, about 2,000 meters cubed per hour of air at an input temperature of about 130 centigrade. So if the person is interested, I can please contact me and I'll try and give them more specific. But
or maybe someone can convert as we are speaking. No, joking.
Hello, thank you very much for the presentation. And I think you partially answered the question, which is drying is around 20% going all the way to 0. And then you mentioned the watering should be taking place in another stage. But for the sake of going faster in materials that do not dewater in a good way, can this technology be applied for a first pass for the watering some materials and then drying?
I'm not sure I may have misunderstood your question, so please correct me. But I wouldn't recommend this for dewatering because it's much too expensive. Okay. There are cheaper ways of dewatering. We can talk separately. It's not a good use of your money, if I may say.
Thank you.
Thank you very much. I have doing a lot of steps today. That's changes from being completely on Zoom. Is this technology suitable for coastal geographical area with high humid air? So somehow, I think, in other words, does the ambient air temperature impact?
It's a good question. So if you look at I think the correct term is a psychrometric graph of the moisture carrying capacity of air versus temperature, which is what somebody in that situation would need to do, it's an asymptotic graph. So basically, you solve that problem if it arises. It depends specifically on what the moisture level is. You solve that problem by increasing slightly the temperature of the transport air. So the way that this works is that having sheared the moisture off the material, we need to keep the transport air at a sufficiently warm temperature that the water does not recondense. So that's all we have to do. It's much lower temperature than boiling it off. So if the ambient air is carrying a lot of moisture, you just need to shift the temperature up so that you continually stay above the dew point. It might be 10 degrees centigrade or something.
Thank you. A last one here? Yes, Jesper.
I'm a little bit curious. How well does your equipment handle very sticky material such as plastic clays?
To be fair, it prefers smooth flowing material. That's actually less for the drying pipe, but more just the material handling difficulties of feeding something, even in a mass flow hopper. The stickier the material, the more difficult it's going to be to get it through a hopper and through a rotary valve into our system. But those are conventional bulk material handling problems that you get in every such facility, rather than specific to this particular technology.
Good. Big thank you. Yes. Thank you very much. I know where it is now for the next one. And I'm moving. So now we are welcoming Fortera. Thierry, I'll let you introduce yourself.
Yes.
And
Thank you. Yeah, now it's on. Thank you. Thierry Legrand, so I'm heading Fortera operations for Europe. So good afternoon, good morning, good evening. And it's a pleasure to explain to you the Fortera's technology. Basically, Fortera has developed a new binder, a new cement inspired by nature, inspired by the way coral reefs are formed. In nature, there are different polymorphs of calcium carbonate. Calcite is a well-known one, the one we find in most of our quarries. But in some quarries, we also find aragonite, and coral reefs are done out of aragonite. But there is a third one, vaterite. It also exists, but it's very reactive and therefore not very stable at ambient conditions. So what Fortera has done is to develop a process to transform mine limestone into reactive calcium carbonate. How do we do that? We first dissociate the lime from the CO2. The lime is dissolved in the process, and then the CO2 is remineralized to form the reactive calcium carbonate. What is the benefit? First, it requires less energy than to produce Portland cement. And second, and I should have said first, the process emissions are remineralized, which means that for each ton of reactive calcium carbonate, we will emit 60% less CO2 than Portland cement. This powder can be used either in blends with Portland cement and other cement issues. And it's how we would save CO2 if we replace some clinker by our product. And this is what we have tested in the frame of the Innovandi Open Challenge. It can also be used pure as a binder. And I will say a word later on the topic. So we have been very happy to have a big consortium with major players. So thanks to Taeo, Holcim, CRH, UltraTech, Argos and GSW, and it was really a pleasure to work with a consortium and to do some tests of blends between our reactive calcium carbonate and Portland cement. So here you see a test with two different types of limestones. You see in green control cement, and you see in blue and black blend with our product with different quality of limestone. High-grade limestone, which gives similar results as the control cement, and a low-grade limestone, which to our surprise gave even better results than the previous blend. In fact, it was to our surprise, but we should have anticipated it, because inside this low-grade limestone, there was some clay, and by calcining, there was a putzolanic effect from the calcining of the clay. What you see in blue is the envelope of commercial cements we have tested in the USA. So we learned in this process that using low-grade limestone could be even better for us than using a high-grade limestone. And what we also experienced is with this low-grade limestone, we first had a flow of the mortar below what we had with the other one. So we had to work on the particle size, to blend the particle size in order to fix that, which was also a good learning for us. So these are the results by a third party, so it will be in the presentation. I won't go into the details. What is next? What is next for us is to work on different blends, and it's on the left, especially low clinker factor blends. So this is a blend with around 40% clinker, and then a mix between our product, calcine clay, and some mineral additions. If you are interested, please contact us and we can go into more details. Really what it is about for this kind of mixes, it's to have higher early strengths and good flow, and these are the topics we are working further on with very encouraging results. And on the right, you see another usage of our reactive calcium carbonate, which the pure usage, when you use it as a pure binder. The transformation of vaterite into aragonite will bring a concrete, a different concrete, that can be used for some usages, such as fiber cement boards. If you're interested, we have some sample of fiber cement boards on the table for people present here. We believe this is a very promising technology. This is a way to have the best out of our technology, because when you use it 100%, you have the full benefit of the CO2 reduction. What is next is also for us the start of our first small commercial plant. So it's in Redding, California, within a cement plant from Cal Portland, which is part of the Taio group. And it will be a 15,000 tons a year plant. We will commission it early next year, so we'll have plenty of product. We keep some for tests, so if you are interested for tests, even in Europe or in Asia, we will bring the product and to make more tests and more further development. Thank you to all the consortium members. We are still to analyze and test further products we have received more recently. Thank you, Devika, on this journey that is just the beginning.
Thank you, Thierry. Thank you, Thierry. We have a few questions. The first one I have is how to handle a high LOI content produced in Fortera cement, since all cement standards have targets for LOI. Loss of ignition.
No, I understood.
Sorry.
How to handle?
So the question is how to handle high LOI content, because all cement standards have target of about 6% max. So I think it suggests that you end up with high LOI with Fortera cement.
I mean, this carbonate at the end we are adding. So this is the same, I would say, from a loss of ignition if you put calcite within the system. So I don't see a specific problems that would be linked to our product in that respect.
Okay, Dilip, if you hear me and if you want to rephrase your question, we still have time to do so. The second question, actually, initially, your process was to use in a rotary kiln. What type of installation is it now?
Are different. We need to produce lime unless we have already a feedstock which is decarbonated. And to produce this lime can be done in different ways. We know that it can be done in rotary kilns or in a flash calciner. Both are possible.
Okay. It's coming through a lot of questions. What's the durability of cement made with Fortera?
We are tests showing good durability. We have some boards done, a few years ago as far as the pure product is concerned. So we have data showing good durability.
Okay. Now, a following up question. How are you going to measure long-term durability, or how are you going to demonstrate long-term durability?
Yes, and we are doing on some of the, on some of the product I have shown you. We are doing tests. We have done tests on sulfate aggression. We'll do tests on carbonatation. So all the battery of tests in order to demonstrate further the durability. Yes, for sure.
Okay. That's probably also a related question. There's a lot of questions about testing and performance. Now the question is, what about existing prescriptive cement standards, and does it refrain upscaling of the technology?
The standards, our technology for the blend can be used in the ASTM and in the European norm. Now for the pure product, it's completely new. So there we will have to go the route of further tests in order to demonstrate what is needed for ETA or for norms.
Okay. I think you have some sample, huh? So the one who were here, they could see some samples. Well, any possibility of carbonation in Fortera cements?
Not, I mean, if it's a blend, you could have carbonation for sure. And as I told you, there will be measurement to be done, but it takes a long time to do this kind of measures. But linked to the vaterite itself, no, because it's already carbonated.
Okay, so that reduces our recarbonation potential, but we can't eat the cake, have the cake and eat it. Another question I have here, can high magnesium oxide limestone used?
Yes, you can use a higher magnesium oxide content than for Portland cement. Usually in Portland cement, you go maximum, I think, up to 5%. In our case, you can go up to 10%.
Okay. And maybe a last one, or is there one here?
A lot. There is a chemist online. Huh?
There is a chemist online. There might be many chemists in the room. I have one here, but just let me read it. So we can say that your technology develops reactive SCMs, performance improvers for low-grade limestone reducing clinker factor.
This is a game, yes. This is a good summary of what it is about. Okay. With a caveat, which you have two directions. One is in blended cement, and the one is a pure binder, which is also an exciting opportunity.
Okay, so Dr. Abhishek Kumar Rai, you have summarized really well this Fortera technology online. Do we want to take a last question from the room here? If not, then big thank you.
Thank you.
Well done. And our last one is Alfredo. He needs his drink to perform. Come in front of the camera. So our last startup is carbon BioCapture. You need this, and I move away. The floor is yours, Alfredo.
Thank you very much. Can you hear me? Yeah. Buenos días. Guten Morgen. Hello. Thank you for the opportunity. I'm here representing Carbon BioCapture. It's a woman-founded company. Andrea, the founder, is right here with us in the room, and I will be doing the presentation on her behalf in English. Essentially, our technology is based on the use of microalgae. This is a natural resource. Microalgae have been around for billions of years and are primarily responsible for the oxygen we have in the atmosphere today. Billions of years ago, the atmosphere had as much as 40% CO2. And the reason we don't have 40% CO2 is because of microalgae. So essentially, what we've done is we've harnessed nature and the ability of these microorganisms to metabolize. That means to turn gas CO2 into lipids, proteins, polysaccharides, essentially biomass. This technology has a 16-year experience already. We are probably the oldest startup in the history of mankind. Okay? What makes us somewhat unique from other microalgae ventures is that we do not use genetically modified strains. Everything we use is found in nature. Not just found there, it has to be location specific, and there's a reason for that I'll explain a bit later. So essentially we, oh, by the way, what you see here on the left, forget it. Anyway, so what's also very unique about our technology is that we do not process the flue gases. These are, I don't know if this is working. Oh, there we go. Essentially, we divert the raw flue gas from the stack and transfer it with a duct using blowers, not compressors, and bubble it through these photobioreactors. There's a full one-to-one scale picture of a photobioreactor in our booth. These are vertical acrylic alveolar panels. And if you can see, the gas diffuses in microbubbles, and it travels the length of the 2 meters, roughly, of the photobioreactors. If you deploy these arrays at scale, then you have what we call a carbon capture farm, or short carbon farm. Essentially, we are farming algae using flue gases instead of atmospheric air. And the reason for that is that air contains 0.04% CO2, but if you feed them 15% CO2 or 6% CO2, you get a much higher productivity, as long as you don't kill them first, with whatever is in that gas. And that is essentially the highlight of our technology. We can use untreated flue gases. We have a measured efficiency of up to 86% absorption, or bioabsorption, and this is like a biological filter of the CO2, as well as a 96% absorption of the NOx and 100% absorption of the SOx. And of course, these are in ppm levels. There's a cumulative 16 years experience with pilot plants. The one above is with AES. It's a utility company in Chile, near Santiago in Valparaíso. And this plant has been running for about 11 years, connected to the flue gas of a coal-burning power plant. The example at the bottom is with Argos, Cementos Argos, in Cartagena in Colombia, in the tropics. As you probably know, Santiago is a temperate climate. It gets snow in the winter, it gets hot in the summer. This is a Caribbean location with pretty much the same conditions throughout the year. We call the technology all-terrain because it is capable of dealing with flue gases of any kind of source. It is also because microalgae inhabit literally every body of water, whether it's the oceans or the caves or the rivers or the ponds or even the puddle that forms under your air conditioning. You will probably find microalgae there. It is modular and scalable. What does that mean? That you can run this technology with 1 photobioreactor or 1 million or anything in between. It's like an accordion. It makes music no matter how much you stretch it. So you do not have to build a minimum size to see if it works. You can make it with a small scale and then add capacity as you go along. In terms of the effectivity, I mean, each one of these reactors we estimate can reach as much as 5, but let's say from 2 to 5 metric tons per photobioreactor per year. The reactors and the frames are rugged, and that's because they were developed in Chile, and as you know, there's an earthquake every week in Chile. So whatever you build there, you don't want to use glasses made of, or tubes made of glass, because they will not survive the first earthquake. You want something that can take a beating and keep working. And because the system is closed, not sealed, but closed, unlike, say, a pond or a racetrack pond, you can actually measure inline continuously the concentration of gases as they leave the reactor. And you have real-time monitoring of the effectiveness of the technology and the productivity. And finally, the technology has received prior consideration from the United Nations. This is an empty wall. Oh, there you go. So as far as the Innovandi Open Challenge, and we're very grateful to Devika and the GCCA and everybody who made this possible, we are now, our target is to achieve a productivity of 40 grams per square meter per day, which would be like doubling the existing capacity that has been measured by Argos in a similar photobioreactor in Cartagena. The goal is to achieve, again, a productivity of 840 metric tons per hectare per year. Currently, the productivity is much lower, and this is part of the challenge that we have set to ourselves to demonstrate to our consortium members. What we will be doing is we're basically running concurrently 4 pilots in the same location with 1 microbiological laboratory and using the facilities of Argos in Newberry, Florida. And we'll do 4 pilots simultaneously using basically strains found from the water samples sent from the members of the consortia. The first part of the project, of the challenge, consists of identifying, characterizing, and then adapting this microalgae to the gases that you would find in a flue gas. Typically, if you take microalgae and expose them to flue gases, you're going to kill them instantly. So what we call our greenware, because we have the hardware, which is the photobioreactor, and the greenware is basically that knowledge that allows us to make this algae not only survive, but adapt and thrive at very high concentrations of CO2, including SOx, NOx, and even heavy metals. The second phase will be to actually build, deploy, and run this pilot at the 1 location in Florida with 1 flue gas and 1 water and weather conditions. If you notice on the left here, what we're doing in the lab, what we have done in the lab, and this has already been done, you can see the results here on the right, for each one of the companies, Argos, CEMEX, CRH, and Holcim, is that each one of these members send us samples, several water samples from their particular plant of choice, which we're not identifying other than by the country of origin. So as you can see, we have Spain and 3 other plants who are in the US in different locations. Each one of these water samples, we discovered that indeed, although they look like drinkable water, there were microalgae in there, and we managed to replicate them, grow them, characterize them. So we have identified, which strains are present in each one of the samples. By the way, it's never a single strain. Well, never, I should say. Most of the time you find a consortium. That means there's multiple strains that cohabit and, in a way, collaborate, but also provide a buffering system to accommodate changes in weather, in salinity, in acidity, etc. And so this is actually what nature does. We did not invent this thing, we just realized this is what's happening and exploit this fact to our advantage. What we do is eventually we expose them in the lab to a facsimile of a combustion gas. And that is based on this composition. So it's about 15% CO2, there's some oxygen, there's monoxide, carbon monoxide, some NOx, and some sulfur. And we use this to train and adapt this algae so we can slowly get them to become resistant and literally very productive at very high concentrations of emissions. I will not go into the identity of the various strains because we were asked by the consortium members to not identify which strains we had. But as you can imagine, each one of those has different characteristics in terms of the growth kinetics, the adaptability, the productivity, and the composition of the biomass in terms of lipid content, polysaccharides, proteins, etc. As far as the path forward, we have already started to fabricate and will hopefully in the next few months start to deploy the photobioreactors. We will then operate them at the actual location using diverted flue gas from the stack. And we will determine how each one of these strains from the various consortium members perform live in the open air exposed to the sunlight because we don't use artificial light. Okay? And these results obviously will be shared with the consortium members. And in terms of the future thereafter, and by the way, you don't have to wait 9 months or 6 months to figure out if this is working. We may discover within 3 or 6 months that this is working really well for this strain, not so well for the other one, or perfectly well. I mean, only nature and time will tell us. So we'll have a comparative analysis of the performance of the various strains by origin, and also of different types of reactors. We're going to try different geometries, volumes of reactors, because the idea is to increase the productivity per hectare for a given amount of space. This is a space-intensive solution. I don't suggest you put this thing in the middle of a city. You need space, okay? Usually the space is degraded soil that is not suitable for agriculture, by the way. And the other thing about it is you can use wastewater or even ocean water or brackish water or processed water. You really don't have to put a toll on the available drinkable water. Eventually, of course, the possibility is that you could deploy this in other locations, other geographies, colder climates, warmer climates, ocean water. And then you can test this on site with the specific climate and water availability and flue gases, which is what, there's no two of them are the same, and test and develop then, the technology for each of the locations of the members. Eventually, of course, you could go and build an entire carbon farm, which basically means you keep adding photobioreactors. Okay? Currently, our estimated packing density is about 12 to 13,000 photobioreactors per hectare. So since a hectare has 10,000 square meters, you figure you have 1.2 photobioreactors, okay, per square meter. As far as the future, we believe that once you have these things deployed at scale, you can actually fine-tune the operation of the carbon farm, determining the harvest cycle, depending on the productivity. Since you can measure it online in real time, you can literally fine-tune the timing of the harvest and the replenishment of the water that you recover from dewatering the biomass, and start using machine learning algorithms to optimize the carbon farm operation and hence reduce your operating expenses. Okay? As far as the future also, by the way, our business model is kind of unique. We don't sell you any of this stuff. We call it carbon capture as a service. We charge a fee per ton of carbon captured. We make the investment, we build, we operate the carbon farm. The client pays a toll, so you can pay a carbon tax or you can pay me that money, but you'll pay less probably, because if you pay me a fixed price, you don't have a risk of ever increasing carbon taxes or even prohibitions, okay? So there's a trade-off. Carbon insurance, we call that. And finally, the plant can also choose to take the biomass and burn it as a fuel, because it is condensed solar energy. By the way, all that shale gas and shale oil that keep getting out with fracking? You know where that comes from? Microalgae. They fossilized and became fossil fuels. Well, we're just doing the same thing all over again with a little help, of course. And finally, in doing that, you can reduce your emissions, your carbon footprint, and do something for your shareholders, your stakeholders, your neighbors, and your grandchildren as well. Thank you very much. That's it.
Yeah, go one slide back. One slide back. There are a lot of questions. So 5 minutes for questions, and then we will, I'm aware of time. Main issue, I think you explained, but the question is carbon biocapture. Main issue with algae is that they are living organisms and can get sick or die. What are you doing for long duration systems?
Well, at some point they're going to die, that's for sure. The idea is to get them to grow. Here to grow them for fun. They become a transport medium and a storage medium for energy, but you can also extract proteins, lipids for nutrition. You can make fertilizers, you can make bioplastics. So it's not about keeping them alive. It's about making sure they stay alive and grow very fast with a lot of CO2.
Okay, and then how often do you need to replace the water?
Okay, so the water is recirculated. What you do is when you harvest, you empty the photobioreactors partially, not all the way. You dewater the biomass, you return all the water to the reactors to start, it's a batch process. You start the growth cycle again. So basically you're diluting it with the replenishment of the recovered water from the dewatering, and the growth cycle starts again. And you continue doing this and separating the solids or the biomass. Okay.
So does it mean you can use the water forever?
There's some evaporation and whatever moisture content is in the biomass that you are removing. But remember, when you have flue gases, there's also some water vapor in there. So you're also adding some water from the CO, from the HO2 from the combustion.
Okay. What's the general duration in days for adaptation process as from the day one of inoculation?
Okay. It takes weeks and weeks. Actually, it takes a couple of months to do the adaptation process. But if you ask me more, I would have to kill you. secret sauce.
Okay.
Andrea will kill me first, so I'd rather not die.
Well, it was someone anonymous asking.
Of course. The same guy.
The same. Well, there are many anonymous person here. And same question as we had for another startup. What about particulate matter content? How toxic is that?
All right, so this is an excellent question. Remember that we said we do not do any pre-treatment of the gases. Atmosphere, whatever is going into that atmosphere is what we're going to be using in our process. We're not going to remove anything else. The biological filter is going to remove whatever is in there. Now, if you have a lot of particles, there's something wrong with your system. You should have, electrostatic removers or filters or whatever you're using. Now, this is because you don't want to have particulates where they start caking up the blowers, okay? So whatever is going into the atmosphere, that's what we are not sending to the atmosphere, we're sending to our plant. So that should be already pretty much particulate free.
Okay, thank you. Another question, how does that work in all climate environment, or how does the climate affect the technology?
That's a very valid question. Microalgae are found in every continent, maybe not. Yeah, and so, of course, they work, and they grow. The question is, does it make sense to put a plant in Finland? Probably not. In Greenland? Absolutely not. Why? Why would you make this investment and try to make them productive in the least of productive places? So you want to stay, within a reasonable place, all the way from New York, all the way to Santiago de Chile, or even, in fact, we're doing a pilot very soon in the very south of Argentina, near Patagonia, not in Patagonia. So yes, you have a very broad spectrum of places.
So it still works as long as you have space, as you said.
Space, correct, yes.
You need space. So I have two last questions on the use. So are there other uses than burning? And then what's the harvesting method? So I guess...
What's the what?
Harvesting method.
The harvesting,
yeah.
Okay. So uses for the biomass. The biomass is what I call a green Swiss Army knife. It's got all kinds of tools that you can pull out. So you can do food, fuel, plastics, fertilizers, pharma, cosmetics. This is a biological factory. But in fact, all the omega-3 that you eat in your diet that comes from fish or from the pharmacy, it all comes from fish, but the fish don't make omega fatty acids. It comes from microalgae. It just goes up the food chain. So that's one thing. The other thing is you can take the oils out. You can add this to fish food for fish farms. Instead of having to catch, and kill fish in the wild, you can just take it out of the microalgae. You can make bioplastics. In fact, you remove the oil portion of the microalgae, and the rest you can make bioplastics. There's a lot of uses. And in terms of the harvesting, I explained this quickly again. You basically drain the reactors partially. You take that liquid, that growth medium, and then you separate the solids, first of all with microflotation, and later you can do the drying with that technology we heard earlier, which sounds wonderful. Or you can do all kinds of other mechanisms to dehydrate it, although most of the times you don't need to dehydrate it. You can go to other finished products without dehydration.
Okay, we see now an interaction between two startups. That's great. Alfredo, thank you. I think we could speak for hours.
Thank you.
But big thank you. I think we should also thank the founder of the company. You are sitting at the back because well done. And language is a barrier. Cheers. So I will invite Thomas again. And while you are walking up, Thomas, I have a question for us in the chat that was there since the beginning. And the question is, what did happen to the startup that didn't make it to the 6 consortium? I think Devika kind of hinted to that on our panel, but we only onboarded in consortia startups for which we had 3 or more GCCA members interested. It's a competition, compliance, competition policy issue, and we also wanted to run consortia where we had enough interest. But we know that there are many bilateral relationships with startups that didn't make it to consortia. We know that some startups, GCCA has taken the policy to issue letter of support to the startup that made it to the pitch day. So whenever a startup is in need of a letter of support, GCCA is happy to provide such letter. And a few startups have even accessed some funding, just having been pre-selected by GCCA. So we have also supported many other startups than the 6.1, but do 6.1, they are working with our members in consortia. And Natama, I think you will explain to us what's next.
Yeah, thank you, Claude. I mean, thanks for this, and what a fantastic display we had. I mean, impressive developments. Okay, I mean, it's not a surprise for us. We knew it. We have went through the process, but seeing everybody together like this, I mean, that's quite remarkable. So thank you very much, guys, for all the developments and for your genius in contributing to the climate change here. Now I want to talk about what's come next. And you know, I had the chance. I was in USA a few weeks ago. Not good for the footprint. I mean, I flew there in eco, and we were exchanging with some Europeans, being in this Pittsburgh Global Clean Energy Action Forum. Right, this was led by the Ministry of Energy in USA. And you had, again, a tremendous excitement and a lot of people talking about startup innovation, etc. And we exchanged with some European there, and we say it's amazing. I mean, in Europe, basically, when you talk climate change, you talk 60% about regulation, a little bit of financing, and very at the end, you talk innovation. And in USA, it's probably the opposite. So you talk 60% about innovation, a little bit about financing, and regulation comes at the end. And the Americans, they do that super quick, super neat, and that's very supportive. I mean, the IRA, for example, is one example of that. So we take the best of the two worlds in GCCA. We take the best of the world. We are a global association, so of course we continue on innovation. Innovation, as I said, is a fundamental pillar of our development. We are not just talking about, you know, climate change, at COP, things like this, but we are also really increasing on pushing innovation. So of course we continue. What's next? Everybody say we continue. We continue with two lines. We will keep open the actual challenge on carbon capture. So we'll make that one work, and we'll keep. So we'll explain exactly what will be the process. But basically, the line is open. So whoever wants to submit a new project, a new startup, a new development on carbon capture, we are very much open to have it. I mean, so we'll go and we'll organize the development, and we will actually launch a second open innovation challenge on a new theme. And this theme is linked to material science. In our roadmap that you might have seen 1 year ago, you can still see it on our website, visit our website. We have actually 5% of the products that comes in 2050 that is from new materials. So no related to clinker, no related to cement. We still call it a cement, but it's a new material. 5%, it's 200 million tons of this material. We have as well to solve a challenge, which is basically the phase out, if we say so, of slag, still becoming more carbon neutral with the help of hydrogen. I mean, not with carbon capture for some of them. So some slag will disappear, and also the fly ash from the coal, the electricity coming from coal will also phase out in many countries because of the situation of carbon. So the question for us is, how do we actually replace this material, and how we grow the quantity and the amount of material that we talk about something in the amount of, I said 200 for the final product, 200 million tons. That's twice the market, the American market, just to give a reference, and probably between 500 million to 800 million tons of material to substitute clinker. In this thing. So the next challenge is very much about that. It's about the application of these materials in concrete. So the concrete application of this material links to material science into the concrete application. So we'll have a clearer explanation than this one in the month to come, and we will launch it in early next year. So that will be the new challenge. So I'm very happy to announce that we continue, that our members are actually appreciated so much the first wave, that we're actually going with the second wave, and that we keep the carbon capture element as well as a permanent feed for development. Thank you very much, guys. You close the meeting.
Yeah, a big thank you to everyone again, to all our guests online. If you joined later and if you want to, or even you, if you want to re-listen to this event, we will, as usual, it has been recorded. It will be made available from the GCCA website. One more time for the one who joined earlier, a huge thank you for VDZ for having hosted us here. It was great. To all the one in the room, we would like to take a big group picture. We haven't done this yet, but I suggest we close this call. We leave the colleagues who are online, unless you want to keep the camera on and that everyone sees who is in the room. That's another option, if we can leave it open another 2 minutes. And then I suggest you all join us here and we try to take a big group picture. Thank you again, everyone. Oh, you suggest we do it outside. Okay, so we will close the call and we take a picture in the reception hall. Yes, on the stairs. Thank you, Martin. You know the building.